Lesson 3-5, solving systems of equations in three variables. So when you have three variables and three equations, these are your possible solutions here. I don't know why the highlighting is off, but it's a little off here. You could have one point or one solution. That happens when the planes intersect in one point. We could have infinitely many solutions. That means the planes intersect in a line. Or you could have no solution, which means that the planes do not have any points in common or they don't intersect at all. Okay, those are the three possibilities. You can see pictures of the graphs on page 145 in your textbook. Because there's three variables, your solution is called an ordered triple. Most of the time it's X, Y, Z, but if you have different letters, they go in alphabetical order. For example, A, B, C could also be the order of your solutions. Okay, so here's the first example. This is a system of three equations with three variables, X, Y, and Z. I need to find the value of each one and then write my answer as an ordered triple. What you're going to want to do here is work with only two equations at a time and eliminate the same variable twice. Okay, so to start, what I'm going to do is work with just the top two equations, and I'm going to eliminate X, just because that seems pretty easy to do. So what I need to do is multiply the top equation by 2, line everything up, and I'm going to use elimination. Okay, so rewriting it, the top equation, everything gets doubled. X times 2 is 2x. 2y times 2 is 4y. Z times 2 is 2z. And 10 times 2 is 20. The second equation now, I'm just going to line it up right underneath. You can see now that I've made the x values match, 2x in each one. And I'm just going to ignore the last equation for now. So here's the first two equations. I'm going to eliminate x. So to do that, I need to subtract everything. Now this is 4y minus negative y. That's really a double negative here. It means add, so I get 5y. Then we have 2z minus 3z. That's minus 1z. And 20 minus negative 5, there's a double negative again, so it's really like adding. We get 25. Now I'm going to use this one later. So 5y minus z equals 25. Now I need to use two separate equations and again eliminate x so that I've got just y and z left in the equation, and then you're going to see what we can do with that. So this time I'm going to be using the bottom two equations. Now notice the x's already match here, so I'm going to ignore the top equation and I'm going to eliminate x by subtracting the columns. So when I do that, the x's cancel out. Negative 1y minus negative 3y is 2y. 3 minus negative 5z is positive 8z. And then negative 5 minus 27 is negative 32. Okay, so what I've done now using elimination, I've eliminated the x twice. And I've come up with equations. You have to eliminate the same variable twice because I've come up with equations now that only have y and z. And we know how to solve a system of two equations with two variables. So now what I'm going to do is solve this system. 2y plus 8z equals negative 32. And my other equation, 5y minus z equals 25. I've just kind of wrote a system now with only two variables, so I can figure out what y and z are using either substitution or elimination, whatever method you like, and then I can go back in and plug those values in to get x later. So because I've got the y's and z's lined up, I'm going to use elimination, and I'm going to eliminate the z's. I can do that by multiplying my bottom equation by 8. Okay, so rewriting this system, the top equation is going to stay the same. 2y plus 8z equals negative 32. My second equation, everything gets multiplied by 8, so I get 40y minus 8z equals 200. Now, using elimination, because I've got a positive 8z and a negative 8z, I'm going to add the columns this time, and I get 42y. Oh, I switched to black. Sorry. These cancel out, and then on this side, we get 168. Okay, sorry about switching colors. Now, divide both sides by 42. And we just found the y value. Okay, now because we have 3 equations and 3 variables, yes, this is going to take you a little longer to find the first answer. But once you do, the rest of it is easy. So I know that y equals 4. I would circle that so that you don't get lost in your work later. And now I'm going to find the z value. And you can find z by using one of these original equations. I'm going to use this second one here, 5y minus z equals 25. So 5 times my y value is 4 minus z equals 25. Well, 5 times 4 is 20. I can subtract 20 on each side to get negative z equals 5. That must be, or mean that z equals negative 5. There we go. So I've first found that y equals 4. I plugged it into this equation to figure out what z is. Now I have 2 of my answers. The last one to find is x. So you go back into one of the original equations that has x, y, and z in it, plug in z equals negative 5 and y equals 4, and then solve the equation for x. I'm going to use the top equation. So the top equation says x plus 2y plus z equals 10. X is what I'm trying to find. I know that y is 4, so I'll plug that in, and I know that z is negative 5, so I'll plug that in. Now, if I solve this, 2 times 4 is 8. 8 minus 5 is 3. So x plus 3 equals 10. I'm going to subtract 3 on each side, and x is 7. Okay, now I'm done. I've got the 3 values. I can put them in alphabetical order in my ordered triple. X comes first, so 7. Then the y value 4. Then the z value negative 5. So there's one point of intersection here for these 3 equations, and this is the ordered triple. Now I could check that these 3 values work in each equation. That would be the way you would check your answer. Make sure that when you plug in x, y, and z, each equation is satisfied. But I want to go through the method one more time with you. You need to eliminate the same variable twice. So I eliminated x with the first 2 equations, and I eliminated x again with the second 2 equations. That gave me 2 equations with y and z, 5y minus z equals 25, and 2y plus 8z equals negative 32. You can then line up these 2 equations and solve for the 2 variables. We figured out y equals 4 and z equals negative 5 using our old-fashioned elimination method. And if you know 2 of the variables, you can easily find the third by picking one of the equations to plug your answers into. And then we got x equals 7. Let me show you another example. So in this one, we've got x, y, and z again, 3 equations, and you need to pick one of the variables to eliminate. I think, again, looking at my variables x, y, and z, I'm just going to start with the top 2 equations, and I'm going to eliminate x again. Because if I look at 4x and 6x, they have a common multiple of 12. Okay, so again, working with the top 2 equations, I'm going to multiply, so I'm ignoring the third one here. I'm going to multiply the first equation by 3 because I want to get 12x, and I'm going to multiply the second equation by 2 because I want to get 12x. Your goal is to eliminate one of the variables, so if I make these both 12, I can cross them out by subtracting. Okay, so rewriting my system here. 3 times 4x is 12x, minus 3 times 6y is 18y, plus 3 times 4z is 12z, and equals 3 times 12 is 36. Second equation, I'm going to multiply everything by 2. 2 times 6x is 12x, minus 2 times 9y is 18y, plus 2 times 6z is 12z, and equals 2 times 18 is 36. Now, what I've just realized here is that I've got the same line, or the same equation twice, the same plane, I should say, because we're in 3 dimensions. So I've got the same plane twice. If I subtract the columns, everything gets eliminated and I get 0 equals 0. This tells me that there's infinitely many solutions here, because I've got two that are exactly the same, two equations that are exactly the same. So when you figure that out, or when you find that, you know that there's infinitely many solutions. Now, the third equation doesn't have to be the same as the other two, and in this case it's not, but I found two that are the same, and so I know that these three planes are going to intersect in a line. So there's infinitely many solutions, and at this point I can stop. There's no reason to solve any further, so we're done with that one. That's good. In this example, I'm going to show you what happens when there's no solution. So you study your equations and you figure out which variable you want to eliminate. I think looking at the A's, it's always kind of easy to look at the first variables. The A's are the easiest to eliminate here. Between 6 and 9, there's a common multiple of 18. So again, working with the top two equations, I'm going to ignore the third one for now. How do I get 18 here? Well, I need to multiply this equation by 3. And I need to multiply the second equation by 2 so that I have 18a. Now let's rewrite. So 3 times everything in the top equation gives me 18a plus 36b minus 24c equals 72. Doubling everything in the second equation gives me 18a plus 36b minus 24c equals 60. Now let's eliminate the a's here by subtracting. Let's see what happens. 18 minus 18 gives me 0. 36b minus 36b gives me 0. Negative 24c minus negative 24c gives me 0. So every variable gets eliminated again. I get 0 equals, but on the right side this time 72 and 60 are not the same, so when I subtract I get 12. Now there's a difference. On the last example we got 0 equals 0 and they were the same line. These are not the same line, however, every variable gets eliminated here and I get an equation that's not true. 0 does not equal 12. And so what happens here is you know that there's no solution. And again, I don't need to continue solving any further. No solution because all of the variables were eliminated and the resulting equation was not true. 0 does not equal 12, so there's no solution. Basically, this means that there's no A, B, and C value, no ordered triple that would satisfy these equations. Okay, one more example. Let's do a word problem here. Jambalaya is a Cajun dish made from chicken, sausage, and rice. I'm guessing those are going to be our three variables. I'm going to use C for chicken, S for sausage, and R for rice, just so you know. So Simone is making a large pot of jambalaya for a party. Chicken costs $6 per pound, sausage costs $3 per pound, and rice costs $1 per pound. She spends $42 on 13.5 pounds of food. She buys twice as much rice as sausage. Write and solve a system that represents how much chicken, sausage, and rice she will use in her dish. Okay, so the first equation I'm going to write is about how much money she spends. So $6 per pound on chicken means 6 times C plus $3 per pound on sausage, so 3 times S, plus $1 per pound on rice, so 1R. And she spent $42 total, so there's that equation. Now we know that there was a total of 13.5 pounds of food, so that means C plus S plus R equals 13.5. And then we need one more equation here, because if you have three variables, you need three equations, and it comes from this next sentence. She buys twice as much rice as sausage. So that means the amount of rice equals 2 times the amount of sausage. So R equals 2S. There's our three equations for this system, and it's actually a pretty easy one to solve. Right away, I can take the bottom equation and plug it in for R, make a substitution. If I know that R equals 2S, I can plug that in for each R in these equations. So just rewriting the system here, we have 6C plus 3 times S plus, now I'm going to substitute 2S in R's place, equals 42. And my second equation, making the same substitution, becomes C plus S plus, now I'm plugging in 2S for the R, equals 13.5. Now what I've got here is two equations with two variables, C and S, so I can solve it using substitution or elimination. Okay, so let me rewrite this. Combining like terms, I'm going to put the S's together so that it's a little more simplified. 6C plus 5S equals 42. And then the second one is 1C plus 3S equals 13.5. Okay, so looking at this system, you could use elimination or substitution. I'm going to use elimination, and I'm going to cancel out the C's. So I'm going to multiply the second equation by 6, and I'm going to rewrite it down here in this area. So the top equation is 6C plus 5S equals 42. Now the second equation, I'm going to multiply everything by 6, so I get 6C plus 18S equals 81. Now I'm going to subtract to eliminate the C's. 5 minus 18 is negative 13S. 42 minus 81 is negative 39. If I divide both sides by negative 13, S equals 3. That means we're going to use 3 pounds of sausage in our jambalaya. Okay, so if S equals 3, I'm going to go back into an easy equation to figure out the next variable, and the easiest one to use would be this one right here. If S equals 3, then R equals 2 times 3, R equals 6. There we go. I've got 2 of the variables done with. Now I need to find C. And the easiest equation to use now would be this middle one right here. C plus S plus R equals 13.5. So that means C plus 3 plus 6 equals 13.5. And if I subtract 9 from both sides, C is equal to 4.5. Okay, so now to answer the question, you would say we're going to use 4.5 pounds of chicken, 3 pounds of sausage, and 6 pounds of rice in the jambalaya. Okay, I don't have a try your own problem here, but we're going to get plenty of practice in class tomorrow. So bring these notes with you tomorrow and we'll practice some together.